So because we know that 6 to the negative 1 is 1/6, we can say that the answer is -1 here, because 6 to the negative 1 is 1/6. How about this one here? Log base 10 of 100 equals what number? Well, 10 to the what power equals 100. What is that number? Well, we know it's squared. 10 squared equals 100 because that's 10 times 10. So this answer would be 2. So you can think about these kind of intuitively, logically. You could follow the directions in ALEKS. That's totally fine in the ALEKS program. I just find that for me, it's easier just to tackle these this way. But you are free to skin this cat any which way you like it. Okay, we're going to move into equations. So we're going to solve a logarithmic equation. This one says log base b of a equals c, solve for x. So we're looking for log base what of 1000 equals 3. All right, let's write that out. Log base x of 1000 equals 3. Okay, so a couple ways to kind of think about this. You could do my circle, which I kind of like to do. X to the third power equals 1000. Then you can think about what number does this have to be? Does this have to be? Think about a number that if you were to multiply it times itself 3 times would be 1000, right? So hopefully you're thinking 10. 10 times 10 is 100, and 100 times 10 is going to be 1000. So x is equal to 10. You could also check this by putting 10 in for x. Log base 10 of 1000 equals 3. Let's check it out. Does 10 to the third power really equal 1000? Yes, it does. So we know we are absolutely 100% correct. So that's one way you could kind of tackle this. The other way is if you rewrite it from the beginning like this, and this you may not like this as much, but some of you might, I don't know, we'll see. Um, so I'm going to take the cube root of both sides of this equation. So when you have an equation, you know you're allowed to do, if you do something to one side, you could do it to the other. So you could take the cube root of x cubed and then take the cube root of 1000. There's a little 3 there. The cube root of x cubed is x. The cube root of 1000 is 10. So just another way to kind of tackle this. I don't know if that's a way that you would like, but I want to give you some options here. Okay, what is this? Solving an equation in the form of log base b of a equals c. Okay, again, we've got similar problem here. Don't be freaked out that it's a fraction. Let's rewrite this. Log base x of 1 over 64 equals -2. So you're actually saying to yourself, x to the -2 power equals 1 over 64. Okay. I keep laughing because they they give you like I guess the most non-intuitive ones on this program, just to kind of get you in the mood for this, but I would much rather they would have given something a little simpler before we build up to this, but it is what it is. We're gonna just keep it moving here. So let's think about this. What number, if you take it to the -2 power, is 64? So this is where it's really good to know your perfect squares, right? Like, 2 squared we know is 4, and 3 squared is 9, and 4 squared is 16, and 5 squared we know is 25. 6 squared is 36. 1 squared is 1. Like, it's nice if you have these memorized. These are perfect squares. These are not prefect, perfect squares. They're perfect. I call them the supermodels of the of the number world because if you take the square root of 1, it's 1. If you take the square root of 4, it's 2. If you take the square root of 9, it's 3. If you take the square root of 16, it's 4. They're perfect numbers. Square root of 25 is 5. Square root of 36 is 6. Let's keep going a little bit further till we can get to maybe something that's got 64 in it. So 7 squared we know is 49. Square root of 49 is 7, another perfect number. 8 squared is, 64. The square root of 64 is 8. Okay, that's what I was trying to get to, is this 8, because we've got 64 involved here. So think about 8 to the 0 power is 1. 8 to the first power is 8. 8 squared is 64. Let's go in the opposite direction because this is sort of the divider. 8 to the negative 1, 8 to the negative 2. So in this video and the last video, I was kind of trying to walk you through a little bit of this pattern here. So if 8 to the first power is 8, what is 8 to the negative first power? Well, it's evil twin, 1/8. If 8 squared is 64, what's 8 to the negative square? Well, it's 1 over 64. It kind of goes with that. So we know that 8 to the negative 2 equals 1 over 64. So that tells us what x is. X has got to be 8. So are you loving these? Um, if you're not loving these, maybe you'll love this last sort of push here at the end of week 14, and that is the properties of logarithms. Okay, so there's three main properties that you have to kind of play with when you're playing in the logarithm sandbox here, at least in this course. We're going to focus on these three properties. One is the product property. So remember, product in math means multiplication. And in log land, multiplication means addition. Multiplication means addition. You might be thinking that's strange. It surely is. Logarithm of a quotient, remember quotient is division. So in log land, division means subtraction. Just going to give you some notes here to kind of throw your way here. So addition, addition, multiplication. Subtraction, subtraction, division. So I just want to focus on those two just for a minute longer here. So what you'll notice is when you have log of the same base and you have m and n, okay, two different variables smushing together, they're multiplying in there. You can separate that multiplication by calling this log base a of m plus log base a of n right there. So you can separate them. So that's where I'm saying multiplication means addition. Same thing here. If you have log of the same base of, let's just say a, and you have m divided by n, you can separate this and call this log base a of m minus log base a of n. So this division means subtraction. So I think about this as this is the collapsed version and this is the expanded version. So this is collapsed, this is expanded. There's another power that comes in handy. It's called the power rule. And what they show you is it's sort of like, I think about it in my brain. Let me write this out here. As this log is so powerful that it has a log and an exponent, this exponent is allowed to travel and land in the front. So notice how this exponent here can come down, and over here it's all of a sudden in the front. So now you're multiplying p times log base a times m. So it's kind of a traveling rule. So we're going to use some of these rules to help us with these. These are the expanded versions. So in my mind, these are expanded, and they want us to collapse it. Okay, so see the subtraction? As soon as you see subtraction between two logs with the same base, go back over to your quotient rule. Division means subtraction, subtraction means division. So notice it's written here like this with subtraction in between, which means you can push them together into one super log as long as you're doing division. So log base 7 really turns into 9 this over 5. Now these boxes are kind of hard for me to draw in, so I'm going to just write this out. Log base 7 of 9/5. So this is the collapsed version, and this is the expanded version. When you see an addition sign, think about multiplication. See this addition sign here? These are expanded out, but you're allowed to collapse them together and crush them together. So as long as you have the same base, which we do, 2 and 2, we can collapse 7 times some number, and it needs to be equal to 21. So they're kind of being a little tricky here. They're asking us to think about what would this number be, that if you multiplied it times the 7, right, it would be 21. Well, we know from multiplication tables that 7 times 3 equals 21. So this should really be a 3, right? Because if you push them together with the addition, and addition means multiplication, 7 times 3 would give you 21. Let's see here. What's this one here? Oh, log base 3 of 1/16. Okay. Well, what do we know about 1/16? First of all, it needs to be written in a power, and this is written in a fraction form. So let's think about 16. So we're going to go back to, I wonder if I wrote that out on my cheater sheet for you all. Nope. So I'll do a new one. Let's do another cheater sheet here. How about when I see 16, I think about powers of 4. All right, so let's walk that through. 4 to the 0 power is 1. 4 to the first is 4. 4 squared is 16. 4 cubed is 64. We can go the opposite way. All right, we know this kind of separates things. 4 to the negative 1, 4 to the negative 2, 4 to the negative 3. Okay, so there's a relationship. Hopefully you're seeing it between here and then. I'm just going to use colors to try to help us with this. Let's use green here. Okay, so if 4 to the first power is 4, 4 to the negative first power is 1/4. If 4 to the negative, excuse me, 4 squared is 16, 4 to the negative square is 1/16. If 4 cubed is 64, then 4 to the negative third is 1/64. Well, that is the money right there. That's what we've been looking for, is something to do with 1/16. Okay, so how could we write that? Well, let's rewrite that. Log base 3 of 4 to the negative 3 equals, okay, now we're going to use this power rule. We have a log and an exponent. So that means this exponent can travel down here and drop off in the front. So we could take that negative 3 and put it right here in front. So it would look like this, negative 3 times the log base 3 of 4. Okay, let me back up because I think it's 1/16 and I was going with 1/64. So shame on me. I should have looked at it a little bit harder. It's really 1/16. So let's rewrite this. So I'm going to scratch this out and we're going to rewrite this as log base 3. Now 1/16 can be written as 4 to the negative 2. Okay, 4 to the negative 2. Now, this negative 2 gets to travel in the front, whee, and drop down. So this becomes negative 2 times log base 3 of 4. Okay, so I think that I need to do this one more time because they actually are forcing us to use base 2 here. And I did not notice that because I was not paying that close attention when I should be. So again, shame on me. All right, so let's take a look at this again. Because they're forcing us to use powers of 2, I'm going to go into my powers of 2. So we know, 2 to the 0 power is 1, and we can keep going with our pattern here. So I'll fix my pattern here. 2 to the 4th is 16. So what color have I not used? Pink. So 2 to the negative 4th is 1/16. So the reason that I am pausing and coming back to this is because they're forcing us to use 2 right here. So because I have to use powers of 2, I couldn't get away with using powers of 4. So I'm going to write this again out for the, what they say, 3 times the charm, 1/16 equals, okay, so we can call this log base 3, and 1/16 can be written as 2 to the negative 4th power. So we're going to call that 2 to the negative fourth power. That's right, like that. Okay, for the third time, this negative 4 gets to go in front. And so now we should match what they're looking for because they're forcing us to use the 2. So it's going to be negative 4 times log base 3 of 2. Sorry about that. Well, I try not to make too many mistakes in my videos, but this one definitely took me a few times because I'm not paying attention close enough. So this answer technically would not have been correct because they want us to use this 2. So we couldn't use powers of 4. We had to use powers of 2. And that's okay. Also, when you put you don't have to put a multiplication sign here. Normally, they just like you to kind of crush it together. 3 of 2, something like that. Okay, let's see here. Let's keep moving. I think there's a little more we got to do. Okay, we got this. Okay, there's a change of base formula for logarithms. Now, this little formula comes in handy because sometimes you might have A, B, and C that are all positive real numbers. A is not equal to 1, C is not equal to 1. If that happens, then you can use the change of base formula, which is this formula here, and just simply divide the two logs. So right now, if they give us this little practice problem, log base 5 of 7, it wants us to use the change of base formula. So we can do that. So we're going to say equals to, now take a look at this, log base A of B, as long as, A is not equal to 1, and it's not, it's equal to 5, right? You can rewrite this using a division symbol. So I'm going to divide that. I'm going to keep my same log bases, so log 5. So see where it says log C, I'm just going to write log 5 over log 5. And then you can, I rewrote this out here because I think this might be helpful. So I took this log base 5 of 7 and just kind of put it down here and said, all right, the base 5 is your A, the 7 is your B. So you can write your same log bases here. And I'm going to get rid of the 5s right here. So log of 7 divided by 5, like that. As a matter of fact, that's not even written very nicely. So let me just try this again. I don't know what's happening to me today. Must be a long day of video recording. I'm getting squirrely here. Okay, here's here's how I would actually just do this without even maybe looking at this formula. I would say log of 7 divided by log of 5. We're allowed to do that. So log of 7 divided by log of 5. And then you can put that in the ALEKS calculator. I'm going to go over there with you now. So let me share my screen. Hopefully you're going to come with me. I'm going to clear this out. So I'm going to do log of 7. And actually, I want to clear that out completely. Log of 7. And then I want to see how I can make a division sign come completely across here. So let me check on that, how to make the calculator do that. And I will be right back. All right, I'm back. It just took me a minute there to figure out how they want us to use this calculator. So let me share my screen. All right, so you got to do this in steps. So I'm going to clear this out. So I want to do log of 7. I want to hit equals. Then I want to divide that by the log of 5. And then I want to hit equals. And 1.209, I guess they want us to go out to the nearest thousandths. So we're going to call it 1.209. 1.209. Let me write that down. And let's come back over here to this camera. Okay. So in the ALEKS calculator, you're going to have to type this in as log of 7, hit the equal sign, then division, then log of 5, and then the equal sign, and you should get 1.209. Let's practice another one of these. I don't think I have one on here. I don't, because we get into the last two little tidbits of word problems. So let's just do a practice one. So I'm going to make one up. How about if you have log base 6 of, let's just say 8. Okay. All right. So how do we get this in our calculator? Well, you can write this as the log of 8 divided by the log of 6. And as a matter of fact, yeah, I think it's fine for us to write that like that. So now we're going to go to our calculator. Remember, we're doing log of 8 divided by log of 6. So let's go back over there. Share screen. Okay, so I'm going to clear this out. And again, I'm going to do log of 8. I'm going to hit the equal sign. I'm going to hit the division by log of 6 and then hit the equal sign. So 1.161-ish. Okay. So just be careful using this calculator. All right. I'm spoiled. I'm going to tell you why. I have this graphing calculator. So this thing does magnificent things. So I could, if I wanted to, is to use my calculator, hit the log button of 8 and then divide it by the log of 6. So these graphing calculators are pretty nice because it'll do it all. I don't have to do any like stopping equals and that type of thing. So for this problem down here, log of 7 divided by log of 5, I could have just typed in log of 7 divided by log of 5 and would have got that 1.209 that we got earlier, which I think was here. So I'm a little spoiled with using this calculator, so forgive me, it took me a second to be able to figure out how to work the brain of the calculator in ALEKS. So just one more practice problem. If you have the log of 3, log base 3 of 2, let's just say, I'm just making these up randomly. So you would type in your calculator, the ALEKS calculator, you would do log of 2, hit the equal sign, then the division sign, log of 3, equal sign. So just be careful on typing that in. If you have a graphing calculator, I suggest using that. Okay, so all of this work in week 14 sort of builds us up to word problems or story problems or real life problems. So here is how you can find the final amount of a loan or investment earning continuous compound interest. Okay, I printed out this list. They give it to you in ALEKS. It's like their list. It's called this list of financial formulas. So they give you this list, they give you what the symbols mean. And so but they don't tell you what these are good for. So I'm going to just sort of try to help you with this. So this right here is simple interest formula. This one here is, I'm just going to go to the ones that we're going to be using, compound interest. And this is continuous. Okay, and this one I like because it looks like PERT, like that old shampoo. You guys are probably too young to recognize that, but it's P times E. Remember, that's the natural log, or E, the irrational number for Euler, times R times T. Okay, what do all these little symbols mean? If you see a P, that's principal. I is interest. R is your annual interest rate. Put a little note here. This should always be in decimal form. You always want to take it not in percent, not in percent. You got your T, which is your time of investment. You have your A, which is the future value or amount accumulated. N is the number of times interest is compounded per year if you're using that compound interest formula. We're not going to be using M and Y, but E that's the Euler's number, which is also the natural log. They're kind of like evil twins to each other. Okay, so here's the challenge. We got Chang. Chang's depositing $1,800. So what is Chang doing here? Money Savers Bank offers a savings account that earns 2.5% interest compounded continuously. As soon as I see this word here, I'm thinking about this formula, continuous interest formula. If Chang deposits 1,800, how much will he have in the account after 7 years, assuming he makes no withdrawals? Do not round any intermediate computations, which means don't pre-round. Make sure you round at the end to the nearest cent. So don't start like cutting off decimals as you go through this formula here. So I'm going to write the formula big. A equals P-E-R-T. So it's PERT. We're PERTing. So let's break this apart. What is A? So A is going to be the future value. Okay. P is the principal. Little r is going to be your interest rate. And T is, of course, time. Okay, so what do we know about this problem? Let's pluck out what we know. What do we have? We know that Chang comes in with 1,800 bucks. That's going to be the principal. So $1,800 is our P. Okay. We know the rate. The bank tells Chang, if you give us your money, we'll give you 2.5% interest. So that's our rate. So the rate is equal to 2.5%. Remember, we want to convert this to a decimal, so you want to divide by 100. So it's really 0.025. Do we know the time? We do know the time. Chang's going to let the bank have his money for 7 years. So T equals 7. So we know some things. We know the P. We know the R. We know the T. Give me an E. So the E is standard. Okay, that is Euler's number. So like E, I think about E as like pi. You know how pi is like 3.14 da da da, right? Let's think about that over here. E is the same thing. It's just an irrationally long decimal number, and it hangs out with the natural log. Okay, so let's put into the formula what we have. So we're looking for A. They're saying us how much money will he have in the account after 7 years, assuming Chang doesn't go in and take any money out. So they're looking for the future value, right? They're looking for A. So we're going to find A. A equals the amount of money that Chang brings in times E raised up to the 0.025 times 7. All right. So the future value of Chang's money is equal to 1,800 multiplied times E, the Euler, um, raised up to the rate times the time. So this we're going to have to be very careful when we put this in our calculator. I'll show you on my graphing calculator how easy it is. Might persuade you to get a graphing calculator, especially if you're going to take some higher level maths. These things come in handy. So I would do 1,800 to get to my E. It's down here on the natural log, but it's up here. So I have to hit second and natural log. That gets me to E. I'm going to put a parenthesis up here. I got 0.025 times 7. So this calculator will handle this business fast. So 2144.24. All right, they asked us to round to the nearest cent. That's 2 decimal places, right? Like think about the wrapper 50 cent, right? It's just 2 decimal places. So I'm going to go out to 24 cents. So Chang walked into the bank with $1,800, left it in the bank for 7 years. The bank said they'll give Chang 2.5% interest. When he comes back in 7 years, his 1,800 has grown continuously to $2,144.24. Now the trick's going to be, how can we do this on the calculator in ALEKS? So I'm going to go figure that out and I'll be right back. Okay, I figured it out. Let me show you. Share screen. Off we go. Okay, so here is the little calculator. So we have to take 1,800, multiply it times Euler, the little e, and it's here. Look at this right here. So e to the x, it's right up 2 above the division. So I'm going to click that. And then I'm going to put 0.025, which is our interest rate, 2.5% in decimal form, times 7 years. And look at bada bing, 2144.24. So this little calculator will come in handy here. I'm kind of digging it. All right. I think we're on our last problem. Yay, we are. We've made it. Okay. So we're on the last problem. Let me just make this a little nicer here. Finding the time required for an investment earning compound interest. Okay, this is probably the hardest one out of this entire week 14. There's algebra involved, but we're going to do this. We're going to do this. I'm going to walk you through it. Rachel deposited 2,500 into an account with a 4.2% annual interest rate, compounded monthly. Okay, as soon as they say compounded monthly, all right, I'm going to be thinking about my compound interest formula, which is this guy right here. Compound interest formula. So the last problem we did, we had continuous interest, so we used this PERT, but we're going to go compound this time. And monthly is kind of important, so we'll talk about that in a minute. Assuming that no withdrawals are made, how long will it take for Rachel to have $4,000? Okay, so we're going to have to do some work. Do not round any intermediate computations and round your answer to the nearest hundredth. So that's 2 decimal places. All right, let's flesh out what we got here. So we know we have this formula. We know she comes into the bank with 2,500. So 2,500 is going to be our principal. That's going to be our P. So let's sketch this out. P is equal to 2,500. Let's see what we got. Check. We know the interest rate. We know that little r is going to be 4.2%. We're going to divide by 100 and change that to a decimal, so it's going to be 0.042. Okay, so we know the rate. Okay, we know the formula to use is compound, and we know monthly. Okay, monthly, if you go look at this, A equals P times 1 plus rate over N. We haven't seen N before. Right here is where it's going to show up. It's the number of times interest is compounded per year. If they say it's monthly, well, we know that there's 12 months in the year, so N becomes 12. They're asking us for time. How long will it take for the investment to grow? So they're asking us to find T. And boy, this one's a tough nut to crack because T is all the way up here saying, nanny, nanny, boo, boo, you can't get me. I'm so high above you. So we're going to have to do some work to get to him. All right, so let's start with this formula here. So we have A equals P times 1 plus R over N, and everyone's raised up to the N times the T. Okay, A. Oh, we forgot to actually flesh that out. A, remember, is the future value. Well, she wants $4,000. So that's going to be A. Let's put that on our list. I almost forgot about you, 4,000. Okay. So A is equal to 4,000 is equal to the principal that she came in with, which was 2,500, times 1. Now, 1 is standard, like brakes on your car, right? You just automatically get brakes when you buy a car. The rate we know is what is the rate? Oh yeah, 0.042. And it's the number of times it's compounding, and it's monthly, so it's 12. So that goes here. It also shows up here, times T. Okay, so this is what we're looking for. This is the nanny nanny boo boo guy. He's like, hey, look at me. Somehow you have everything you need to come find me, but it's going to be a bear to get to me. So let's see if we can break this down slowly here. First, I'm going to rewrite this problem with the parentheses kind of taken care of. Like I want to take care of what's going on in here. So I would probably do 0.042 divided by 12 and then add 1 to it. So for order of operations, you want to divide inside the parentheses before we add. So this you can do on any calculator, 0.042 divided by 12 and then add 1 to it. So it's 1, what's going on here is 1.0035. Okay, so let's rewrite out what we have. So for me, that would be step 1. Take care of that. And I still have 12t. Okay, we're in equals land, which means we're in algebra land. What you do to one side, you can do to the other. The whole goal is to get this t by itself, but we have all of this other stuff going on with it. So you are allowed to take 2,500, which is trying to multiply to all this, and the multiplication to undo it in algebra is to divide. So we're going to do 4,000 divided by 2,500. That's going to cancel that out and kind of start to shrink things down. 4,000, again, you can do this on any calculator, 1.6. Okay, So 1.6 is equal to 1.0035, 12t up here. Okay. What are we going to do next? Okay. Do you remember, and it was in this video, I'm going to go back to it. We briefly, very briefly, looked at this rule here. Remember this rule, this power rule? Um, this is where we can actually take an exponent and move it to the front and get it from up in exponent land down to like home base here. Only if we have a log, right? So this p was up here, but now it's down here. And that's where the t is. If you'll notice, the t, the nanny nanny boo boo t, is way up in the top here. But I want to get him down to my level so I can get a hold of him, figure out what he is. In order to do that, we have to give both sides a log. So in algebra, remember, life isn't fair, but algebra is. So I'm going to give that side a log, and I'm going to give this side a log. Okay, once you do that, that allows you to get this nanny nanny boo boo t down in front, which is what we want. We got to get him out of there and down in front so we can find him, find out what he is. Because what we're really looking for is how long is it going to take for Rachel to have 2,500 grow to 4,000? How many years is she going to have to leave this money in the bank? So I'm going to rewrite this as 12t times the log of 1.0035. Okay, now we're cooking with bacon here. Now we can figure out what t is. So think about what's happening over here. We got 12 times t times the log of 1.0035. I want to get t by itself, and because they're all multiplying, guess what I'm allowed to do? I'm allowed to divide, as long as I do it to the other side. So I'm going to get rid of the 12 by dividing the 12, dividing the log of 1.0035, leaving me t by itself. If I do it here, I cannot forget to come over and do it here. 1.0035. Okay, what does this leave me? That cancels, leaving me t, we're almost there, is equal to this. Now this, we can actually type in our calculator. I'm going to show you on my graphing calculator first, and then I'm going to show you how to do it on ALEKS once I figure out how to do it on ALEKS. So I'm going to type in for mine, I'm going to type in the log of 1.6 divided by, and I'm going to put this in parentheses, 12 times the log of 1.0035. Okay. All right. 11.21 years is how long Rachel's going to need to leave her money in the bank to turn that 2,500 into 4,000. Now, this is beautifully done on the graphing calculator. Now the challenge is, how do I get your ALEKS calculator to do the same thing? Challenge accepted. Let me go. I'll be right back. All right, I figured it out. Come with me. Let's go see. You probably already know how to do this by now, but I'm going to show you. Okay, so I would do this in steps. Clear out this thing. The first thing we need to do is type in log of 1.6. That's the numerator. Hit equals. Divide it by 12 times the log of 1.0035, and then we should get 11.21 years. So you just have to do it in a couple steps from what I can tell. If you can figure out a way to make it do it all at once, more power to you. I can't. Well, I guess what I'm saying is I shouldn't say I can't spend the time right now and waste your time while I try to figure out. But if you can figure it out, that's great. So it's going to take 11.21 years. Okay, I think that's it. And I will see you in week 15, where I'll go over some tricky problems that you might face on your practice test or your real test. All right, you've made it. Bye.